Okay, the question says find the inverse Fourier transform of the following. But here we have only one question. Let's try and see the inverse of this question. Solution. Okay, let me sit down. If I have 2j omega plus 5 all over j omega squared plus 5j omega plus 6. When we look at the denominator, we have j omega squared plus 5j omega plus 6. We have to find two numbers in which, when we add these two numbers, will give us 5j omega, and when we multiply them, will give us what? 6. These two numbers will be what? 2 and 3. Now we have 2j omega plus 5 all over j omega squared plus, we have to find out two numbers in which, when we add them, will give us what? 5 plus 5, and when we multiply them, will give us 6. We have 2j omega plus 3j omega plus what? 6, because 2 times 3 is equal to 6, and 2 plus 3 is equal to 5. So this is our sum, and this is the product. We have 2j omega plus 5 all over j omega here. We have to find the what? Common factor here. J omega square plus j omega and what? 3j omega plus 6. We find out the common factor here. We have j omega into j omega plus what? 2 plus 3 open brackets j omega plus what? 2 close brackets. So if I have 2j omega plus 5 all over this, when we look at the bracket alike, the two brackets that look alike, so we take only one bracket, so that we have 2j omega plus 5 all over j omega plus 2 into what? J omega plus what? 3. Now we can resolve this into partial fraction by saying we have a all over j omega plus 2 plus b all over what?